Hello everyone, today we will be learning about the reactions of metals with oxygen. Now metals react with oxygen to form metal oxides. So when they react with oxygen, they would form metal oxide under this reaction. So a metal would react with the oxygen and they would form metal oxide. Now let's take one example. We have magnesium here reacting with oxygen, and it would produce magnesium oxide. The chemical equation for that is Mg, which is magnesium, reacting with O2, which is oxygen in its gaseous form, because oxygen is a diatomic particle, has O2, two of the oxygen atoms bonded together, and then we have magnesium oxide, which is MgO, and it's all balanced, and you've written the states down because it's very important. Then we have iron reacting with oxygen. Now iron here is going to be 3, which means it has a valency of 3. Usually you would specify that, forming iron 3 oxide. Now when you're writing the chemical equation for that, it is important to write that iron has a valency of 3. In other words, since iron is a transitional metal, we actually don't know its correct valency. So the valency may depend. So it could be iron 2 or iron 3 depending on the compound. At the moment, it's given as iron 3, so the valency is +3. And oxygen has a valency of 2, so it's -2. Now, when you react these together, your compound is going to be Fe2O3, like that. So Fe2O3, that's our iron 3 oxide. Now, you can see that iron reacting with oxygen giving us iron 3 oxide. Very simple like that. Now let's look at some reactivities. Metals vary in their reactivity and their behavior. In other words, different metals have different reactivities, and the way they behave with oxygen is dependent on their reactivity. So let's take one look here. We have tarnishing when exposed to air. So different metals tarnish. Let's look at what these metals are. We have lithium, sodium, potassium, and therefore they are stored in liquid paraffin oil. Because they tarnish in the exposure to air, they're stored in liquid paraffin oil to prevent the tarnishing. So let's take an example of the tarnishing. Here we have sodium reacting with oxygen, and sodium oxide is a tarnished version of the sodium. So it'll be coated on the sodium here. Now, some of the metals catch fire when exposed to air, so these are very reactive, such as rubidium and caesium are one of the most reactive. If you go to your left and towards the bottom of the periodic table, you'll find the most reactive elements over in the bottom left. So therefore, they must be handled in an inert gas environment. Now, inert gases such as argon are not reactive at all. So it's not like air or oxygen containing air. It doesn't have any reaction. So rubidium and caesium are usually stored in argon containing air. Some burn readily in air, releasing large amounts of heat and light. And these are magnesium. So for example, magnesium, I think you may have done this in school where you burnt a magnesium strip. When you did this, a very bright flame like that over there was exposed, and this is the burning in the air to produce heat and light. We also have calcium. You probably didn't do this at school because calcium is a very unstable metal, and strontium, barium. Now burn in air if the metal is finely divided. Now why would it make a difference if it's finely divided is that when you finally divide something, you increase its surface area, which means that little volume, greater surface area. So it's easier for the burning or the heat to be dispersed in the molecules. So we have aluminium, zinc, iron. Here's a reaction of the burning in air. So we have aluminium reacting with the oxygen to form aluminium oxide, and this is very easy. So aluminium has a valency of 3, and that's why there's a 3 next to our oxygen. Oxygen has a valency of 2, that's why there's a 2 next to our aluminium here. reacts slowly with oxygen when heated. Some metals react slowly, but when it's heated. So it needs some triggering or a provocation to be reacted. So these ones are copper, and copper here is undergoing combustion. So you can see copper reacting with oxygen to form copper oxide. Now copper has a valency of 2. That's why there's no valencies here. So because oxygen has a valency of 2, they cross out. Do not react with oxygen in the air even when heated. Now these metals we are talking about now are very unreactive. In other words, they're very stable. And they are silver, gold, platinum. So now let's summarize what we just learned. We have very rapid reactions happening with potassium, sodium, calcium. Then we have rapid reactions happening with magnesium, aluminium, zinc, and iron. Then we have slow reactions on the surface happening with tin, lead, and copper. And we have no reactions happening with silver and gold. So these chemical formulas are found in the periodic table, so you can link them or correspond them to their actual name. Now let's look at corrosion. Corrosion is when a metal reacts with gases in the atmosphere to form new substances. Now corrosion is a very big problem, and you may have encountered it as rusting of iron nails in your everyday life. Now metals that corrode may lose its strength. So a metal's property as its physical strength is lost as it corrodes. Metals may react with the following gases to corrode. It may react with oxygen, carbon dioxide, sulfur dioxide, and hydrogen sulfide gas. Here are all the chemical formulas for each of them. I have written them down so you become familiar with them. Oxygen is O2, carbon dioxide is CO2, sulfur dioxide is SO2, and hydrogen sulfide is H2S. And you can see that S has a valency of 2, and that's why there's a 2 next to H. The main corrosive agent in the atmosphere is oxygen. So this is a main corrosive agent. Therefore, corrosion generally refers to the reaction with oxygen. However, the best known form of corrosion is the rusting of iron, and you would have encountered this several times. However, most metals do corrode to some extent. Even though we're more familiar with iron corroding, most metals do. Some at a microscopic level, so we don't actually see it. The corrosion of metals cost Australia several $billion annually. So it's clearly a very costly process. I mean, it has very bad disadvantages as well. A better understanding of the process and the application of appropriate preventive measures could save much of this cost. So clearly, Australia could benefit with an appropriate preventive measure to better make this corrosion of metals, make it better for us economically. And this is something you would write for your extended response, where they're asking for social or economical disadvantages or effects of corrosion of metals. And this is something you would provide as your answer, to talk about Australia and its economical disadvantages due to corrosion. In normal atmospheric conditions, microscopic surface film forms on metals. So as you can see in the image there, there's a very tiny microscopic oxide layer forming on metals. This is the oxide layer, and it is formed on the metal when the metal reacts with the oxygen in the air. So when metal reacts with oxygen, it forms metal oxide, and it is an oxide layer formed on the metal. This is a reason that they lose their luster, because usually the oxide layer is less lustrous, so the metal would lose its luster due to the oxide layer. The layer can be removed by abrasion using steel wool or emery paper. So if you rub steel wool against a magnesium strip that has developed magnesium oxide on it, you would clean it and make it shinier. By doing this, what you're doing is you're actually removing your magnesium oxide, which is a white powder, making it less lustrous. The oxide layer formed on aluminium is inactive. So what happens is there's an oxide layer happening on aluminium, and when removed with using abrasive action, it is readily formed again. So once you remove the oxide layer on aluminium, it forms again. The oxide layer is impervious to oxygen, therefore protects the metal from further oxidization. In other words, this layer acts as a protective agent because it doesn't let any oxygen through. It stops oxidization or corrosion in metals. This is why aluminium and chromium do not corrode very rapidly in air. Because it stops the corrosion, the oxide layer, the corrosion stops, making them not very rapid corrosion in the air. So not very rapid corrosion is happening. However, this is not the case with iron. The oxide layer formed on iron is porous, which means it allows the oxygen to come in contact with the metal and cause further corrosion. Rusting is accelerated by the presence of water. So if there is water molecules in the air or even in the atmosphere or the environment around the metal, then rusting is accelerated. So let's take an example here how water can accelerate the process. Here we have iron reacting with oxygen and there's going to be water in the presence. When they do this, it's going to form this molecule that has water attached to it, and this is rust. So you have iron oxide with a water molecule attached to it. It's not formed again like without it, it's actually attached to it. It's part of it, and that's why a small dot is signifying it. So this corrosion in iron occurs in solution. Also in humid atmospheric environment, because water is needed for the rusting of iron, it happens in either solution or humid atmospheric environment. Now, effects of rusting. There's a loss of metal, which is when metal is lost. Also, it is dangerous as structures such as bridges and buildings corrode, because when they do corrode, the strength of the metal decreases and metal is lost. So, they could collapse. And also in the corrosion of electrical connections, they actually reduce the proper contact between the terminals and the leads. So, poor electrical conductivity due to rusting. And also it corrodes fittings such as lids, nuts and bolts, and often jamming. So the corrosion products swell and fill the place between the two parts. So corrosion is actually acting as a disadvantage here. Also, tanks, pipes and car radiators may leak as corrosion creates holes in the metal walls. So these are some defects of corrosion. Now in this topic, what we just covered was the metals reacting with oxygen, and corrosion was one of these reactions and how it's a disadvantage to everyday society.